Let's look at a word problem that'll lead us to using law of cosines. So we have a golfer, takes 2 putts to get the ball into the hole. The first putt rolls 10.2 feet in the northwest direction. Just gonna highlight that. And the second putt, I should say putt, sends it due north 3.7 feet into the hole. So how far and in what direction should the golfer have aimed the first putt to get the ball into the hole in 1 stroke? Okay, so let's draw a picture here. So what I'm going to do is I'm going to start kind of down low here, and we're going to kind of be heading north with our golf game, I guess. So let's say I'm down here and I'm standing right here, and I'm going to go ahead and draw my compass. So north, east, south, west. And the first putt goes 10.2 feet in the northwest direction. Now, if it just says northwest, it doesn't give any degree measurement, then what you're doing is you're going exactly halfway between north and west. So what we're going to do is cut right halfway, so we have this 45 and 45. So, and then I'm going to go 10.2 feet. So let's say I go something like this. And then what we would have here is 45 degrees. Just make a little note of that we cut that in half. All right, and that distance there is 10.2. And then from this location, we take our second putt, and that goes 3.7 feet north. So what we could do is, we think of our compass here. So north, east, south, west. We're just going directly north of here. So that just means from this location, we're following north. So we're just gonna go north 3.7 feet. Maybe something like that. And end there, which is the hole. So what we're trying, and I'm actually gonna get that compass out of there. There we go. So what we want to know is, what if we just wanted to do this in 1 stroke instead of 2? So visually what that would be is, from my starting point, what if I had just been able to correctly get the angle and the distance right? Something like that. So we want to know that distance, and we also want to know the angle measurement. So we have an unknown distance there. We have 2 of our side lengths, and let's see if we can find some other angle measurements in here. Let's actually zoom in right here to this angle measurement. So let me kind of draw my compass there again. So this piece right here, we came at it from a 45-degree angle, and in fact that's how it hits right here. We have this 45 and 45 right here, and then with due north we have this 90 degrees. So this total angle measurement right here, because of how we're working with our compass, we can calculate it by taking 90 plus that 45 from going exactly northwest. So we actually have that angle measurement based on how these directions are working, and that's 135 degrees. Now if I zoom in to my angle down here, something we can do is, we eventually want to work with some sort of direction for sending the ball. So with that, we kind of want to find, where is this red line cutting, whether we look at this angle here or this angle here. For now, let's just say I'm interested in looking at this angle. I'll call that, let's just call it alpha, as an angle that's inside the triangle that we want to solve for. And then we'll come back to that 45 degrees once we get some solving done. So with the setup of this, in terms of what we know, we have one side, an angle, and another side, which means that all of this sets up to be side, angle, side. So we don't have enough information to use law of sines, so that's where we're going to be using law of cosines. So first, let's just go with solving for this side length here. So let's say I want to find x. So for law of cosines, that would be x squared. And then I would take the other side length squared, so 3.7 squared plus 10.2 squared minus 2 times 3.7 times 10.2 times cosine of the angle that's opposite of x, which is 135. So this is that nice case where all of this can just go into the calculator. So if we plug all of that into the calculator, that should simplify to 171.10. And then we're with x squared here, so I need to take the square root of both sides. So x is equal to 13.08 feet. So right there, that answers our question about how far. We've taken care of the how far part. We know that's 13.08. Now what we need is direction. So with that, let's look at alpha. So for alpha, what we can use is law of sines. Now we have a nice pairing with this side length and the angle opposite of it. So we have sine of 135 degrees compared to 13.08. And then what we can use is that sine of what I'm calling alpha over, and then the side length that's opposite of it, which is the 3.7. And then solving for alpha, we should end up with, we want to take the inverse sine of 3.7 times sine of 135 over 13.08. And plugging that into the calculator, that's giving us 11.54 degrees. So with that, let's zoom into what's happening here. And it's all between north and west. So what I'm going to do is I'm just going to kind of draw north, west. And what we had in there was we had this cut of 45 degrees from kind of how we hit the first shot. And then we had this red line coming through of the angle that we should have shot it at. And what we just found was this angle in here, which is 11.54 degrees. So we want to talk about in what direction should we have hit the ball. So if we were standing here, there's a few ways we can describe the trajectory of this red line right here, because that's what we want to describe. What's the direction of that red line? So two ways we can describe it. We can talk about it being west of north. We could talk about it in that direction, which would give us this angle measurement right here. Or we could talk about it north of west, and in that direction, that would also work as well. Basically, we want either that blue angle or that green angle, and then we just need to be careful with how we describe it. So I'm going to go ahead and do both, but in terms of a written assignment, you can choose whichever one you want to. So if I want that blue angle there, what I would do is think about how the black line here is a 45-degree angle, but we want to take out that 11.54. So I'd take 45 minus 11.54, which should be 33.46 degrees. So how I would phrase that is 33.6 or 46 degrees. And it's like we moved away from north, so we went west of north. Then the green angle there, what that would come through as is 45 degrees plus another 11.54, or you could take 90 degrees minus that 33.46, but let's do it this way of 45 plus 11.54, which is 56.54 degrees. And with that one, we'd be describing it as going away from west, we'd be going north of west. So I would describe that as 56.54 degrees north of west. So either of those work. You can choose whichever one you like in terms of a description. I believe I see this kind of terminology like north of west, south of east, things like that more often, but either is good with me. So that's our application there. I kind of took a side route, but in terms of how far, using law of cosines to get that direction, and then to find the direction, using the angle measurements and then making a description.